Hi there. This video is just going to quickly talk about all the numbers that are out there. I know that's kind of a general thing to say, but in math we deal with numbers, and someone went to the trouble of putting all of these numbers into groups. Okay? And so what I'll do is I will refer to this page that you're looking at right here, especially this right here, but this too. We'll be referring to these as we go through a chart on the next page, because the chart on the next page will start with the natural numbers. We'll explain what they are, and then move to whole numbers, integers, rational numbers, real numbers, irrational numbers, and then something strange called imaginary numbers. And a mix between imaginary numbers and real numbers would be what's called complex numbers. So let's look at the chart on the next page. Okay, very first one, natural numbers. This is the one that's the very beginning of our chart right here, or our diagram. Okay, the symbol for natural numbers, they often talk about natural numbers, they just put the capital letter N, and it's the counting numbers starting from 1. Okay, not starting from 0. So like 1, 2, 3, and so on. These numbers do not go negative too. There's no negative 1, negative 2, negative 3. It just starts with 1, 2, 3. Maybe it's the very first numbers that were ever invented. Okay? Later on, someone came up with the idea of 0, starting at 0. So all the natural numbers and when they start from 0, suddenly they are called whole numbers. It's almost the same thing as natural numbers, but anyway, I believe it's capital W for the symbol. There it is. And it's 0, 1, 2, 3, and so on, forever. Okay? Next one, integers. Well, or integers. No, I'm just kidding. It's integers. These numbers go backwards as well, like they go below 0. Okay, so you could have negative 2, negative 1, 0, 1, 2, and it goes forever that way. It also goes forever this way. Okay, so negative infinity to positive infinity. All right, so all the negative numbers and all of their opposites. By the way, opposites means, well, negative 2, the opposite of negative 2, is 2. The opposite of negative 1 is 1. I'm not sure about 0. I guess 0 doesn't really have an opposite. It's just itself. All right. Anyway, integers most often with the capital I. That's most often the symbol. Rational numbers. Let's just read what a rational number is. It's a number that can be written as a fraction whose denominator is not 0. So in other words, it's just a fraction. Okay? It can also be in decimal form. Rational numbers terminate or repeat. All right? Rational numbers terminate or repeat. Well, what's the symbol for rational number? The letter Q. Okay, so let's just give you some examples of rational numbers. 2/3 is a rational number. Oh, yes, it says a rational number when it's in decimal form. By the way, if you take your calculator, go 2 divided by 3. Let's do that real quick. 2 divided by 3. Look at that. It's repeating here, isn't it? And it's going forever. That 7 at the end is only there because the calculator decided to round off. It's actually going forever as 0.6 repeated. Okay? So 2/3 is a rational number. It's 0.6 repeated. The way we write repeat is with that little line there. Let's pick another one. 1/3 would be the same. It'd be 0.3 repeated. Some of them terminate. So in other words, okay, let's pick an easy one. 1/2. Is that a rational number? Yes, it is. You get 0.5. It terminates. It does not repeat, and that is allowed. Okay? So hopefully that is clear to you. That is what a rational number is. An irrational number is a number that cannot be written as a fraction. And in decimal form, irrational numbers do not terminate or repeat. Okay? So an irrational number. So an irrational number, the symbol is a Q again, but with a line over the top, I believe. Let's look on the next page. Yeah, Q with a line over the top. It doesn't mean that the numbers are crazy, but it is a number that can't really be written as a fraction, and if you write it as a decimal, it does not repeat and it does not stop. So can you think of a number that you've seen or heard of that goes on forever and it doesn't repeat itself? Can you think of a famous one? The one that comes to mind for me is the number for pi. Now most of us just know it as 3.14. Whoops, 3.14. But in reality, it really keeps going on and on and on, and it doesn't repeat. It doesn't have a repetition. Another strange number like this, which is called an irrational number, and we have to include all numbers, so that means the strange ones are allowed too, right? They're important too. The square root of 2, if you were to do that, actually, to show you that, maybe I'll show you on the calculator again. Let's do the square root of 2. Square root of 2. Whoops. There it is. This is a number that does not repeat and it does not stop. It keeps going forever. Okay? Another one, the square root of 3. Look at that. It keeps going forever, but it does not repeat. It doesn't have a pattern. Okay? So, yeah, that's what an irrational number is. Now you know. The next one is the real numbers. The real numbers are symbolized by a capital R, and the real numbers are all rational and irrational numbers. So it's all of the above. It's all of this. Okay? The real numbers are everything that we've described so far. Okay? So I'll just put an arrow. All of the above. Okay? Then we get something called imaginary numbers. And now, imaginary numbers, some people have written it with a small I, some people write it with a capital I. But when you write it with a capital I, that's confusing because it looks a lot like integers. So when you are talking about imaginary numbers, sometimes people that are talking about integers change the letter I here. They change it to the letter Z. I'm not sure why, but it helps to distinguish between integers, which starts with I, and imaginary numbers. Just for your information. Okay, so imaginary numbers, I mean, I've seen them like this often too, just with a little I. But anyway, an imaginary number, it's the result of square rooting a negative number. So if you were to do this on your calculator, the square root of -2, it's actually impossible. It simply can't be done by a calculator. It'll say error because you're trying to take the square root of a negative number. So if we try to take the square root of this -2, invalid input. Your calculator does not like that. So someone came up with this idea of imaginary numbers to help us deal with negative numbers underneath a square root sign. And somehow we're still able to make calculations once we use imaginary numbers. We can still deal with them. Okay? We're not really talking in this lesson about how we're dealing with them. We're just talking about what imaginary numbers are. They are called imaginary for a reason because in math they don't really work. Okay? Now if I look back at this chart here, okay, remember this, these integers here could also be like a Z. Yeah, imaginary numbers could be an I. And what else? Oh yes, complex numbers are a mixture between real numbers and imaginary numbers put together. Okay? And we've just covered basically all of the number sets that are out there. At least you have an idea. And we'll leave it at that. Have a good day, everyone. Take care.